So we're going to talk now about 1.8 part 2, solving absolute values inequalities. So we went over the equations in part 1 and we're going over inequalities in part 2. They want us to use the following properties to solve inequalities that involve absolute value. So when you have, for example, an x is less than c, remember that could be a positive or a negative c, so that's why it's included. It's same if it were less than or equal to, it's just with a closed circle. If you have x is greater than c, again, you're going to have negative c and positive c, so again, it's going to go into the opposites. And same for an or equal to. So this just requires practice, but you solve the equations the same way, you solve the inequalities the same way you would solve the equations just like part 1. But instead of an equal sign, you have an inequality. And depending on how the inequality looks, they're going to point to the middle or they're going to point outside, out to the outsides. And you can always check this by plugging in a number. So if you forget which one's which, you're always welcome to just plug a number in and try and figure it out. So again, we're going to be solving this absolute value inequality. We'd start the same way that we did for the equation. So we're going to do, well, x minus 5 is less than 2. And then x minus 5 is less than negative 2. So you add the 5, you add the 5, you get x is less than 7. You add the 5, you add the 5, and you get x is less than 3. So again, you always write them from most negative to most positive. So it's going to be 3 to 7. This follows the very first inequality. That is, the absolute value is less than a number. So it would be like this. Now you can check this by plugging in numbers, but if you plug in 4, 5, or 6, they fall into the category of between 3 and 7. So just keep that in mind. You can always check it. These type of inequalities are considered AND inequalities because they go towards each other. So I'll write that in. So they go towards each other, they're considered AND inequalities. If they go against to each other, they're considered OR inequalities. This one I would say, well, x is less than 3 and x is less than 7, so we'll go together. So 3 to 7. And then for the other ones, once we get to it, I'll let you guys know. It would be an OR inequality, so they point the opposite ways. So again, here we're going to do x is less than or equal to negative 5, and x is less than or equal to 5. Since this follows the very first, what's this thing called? The very first line, this is going to be towards each other. So this is going to be an AND inequality. So it's going to be negative 5 to 5. I'm going to refer to the first slide as 1, 2, 3, or 4. Well, technically this one's 2, but it's still with the inequality pointing to the left. Now here we have 2x is less than or equal to 20. And a 2x is less than or equal to negative 20. Oh, something I forgot to mention. I just realized I haven't done it yet. Whenever you make it a negative, you have to flip that inequality. So this one, my bad, I forgot to do it too. Let me just, before I forget. Because you're technically multiplying by a negative number, it flips it. Forgot about the rule. I told it to you guys when we went over inequality. I just forgot to apply it right now. I'll divide by 2, so we get x is less than or equal to 10. I'll divide by 2, and we get x is greater than or equal to negative 10. They're pointing towards each other. This one's pointing to the left. This one's pointing to the right. Keep in mind the negative goes first, so it's going to be negative 10 to 10. For the next one, I'll put the negative one first, so they point at each other properly. I just keep doing positive first. So again, it's going to be 2x. We're going to flip it because it becomes negative. And then 2x is greater than 7. When I divide by 2, I get x is less than negative 7 over 2. And this one I divide by 2 and get x is greater than 7 over 2. Now, I know I've been doing it backwards for the most part, which is doing the positive first. But if you do the negative first, you're actually left already from the most negative to the most positive, like 99% of the time. So you'll be able to tell, well, this one's going out, and this is going out, so this is an OR inequality again. So you're able to just write from negative infinity to negative 7 over 2, and the union 7 over 2 to infinity. For the other ones, if I would have written them with the negative first, you would have noticed how, let's do number 2 right here. X is less than or equal to negative 10. X is less than or equal to 10. They're pointing towards each other, so there's an AND inequality. I'll try to remember to do the negative first so they can point at each other, and we can figure it out from there. So for number 4, we're going to go ahead and do the x minus 4 is greater than or equal to negative 10, and the x minus 4 is less than or equal to 10. I'll go ahead and add the 4 on both sides, which will give me x is greater than or equal to negative 6. Again, plus 4, so we get x is greater than, less than or equal to 14. Notice they're pointing towards each other. So this is going to be from negative 6 to 14. Again, I can say they're pointing at each other because the x is on the left. If the x would be on the right side, then I can't say that. Just make sure you try to keep the variable on the left. It's the only way you can for sure know which way they're pointing if you just follow the inequality. We do the same thing for 5. So we get x minus 3 is less than negative 9, and then x minus 3 is greater than 9. I'll go ahead and add the 3, and we get x is less than negative 6. We add the 3, and we get x is greater than 12. This one's pointing left. This one's pointing right. So it means it's an OR type of inequality. So it's going to be from negative infinity to negative 6, union 12 to infinity. So kind of as a tip, just try to do the negative first. It'll probably make it easier to see what the heck's happening. I'm just now doing them with a negative first. I know for the first few ones I didn't, but it's helpful if you do the negative first. So for 6, for example, I'm going to do, x plus 1 is less than or equal to negative 1, and x plus 1 is greater than or equal to 1. So I'm going to go ahead and subtract the 1 on both sides, and we get x is less than or equal to negative 2. We subtract the 1, and we get x is greater than or equal to 0. Again, they're not pointing towards each other. So this one's pointing left, this one's pointing right. We get negative infinity to negative 2, bracket, union, bracket, 0, comma, infinity. So it's going to be from most negative to most positive number. When I do number 7, I'm going to get 2x plus 1 is less than or equal to negative 3, and 2x plus 1 is greater than or equal to 3. I'll subtract the 1 to get 2x is less than or equal to negative 4. I'll divide it by 2, and we get x is less than or equal to negative 2. For the next one, I subtract the 1 to get 2x is greater than or equal to 2. When I divide it by 2, I get x is greater than or equal to 1. Again, this one's pointing right, this one's pointing left, so they're not facing each other. It's going to be negative infinity to negative 2, bracket, union, bracket, 1, comma, infinity. All right, so for number 8, I'm going to go ahead and do 5x minus 2 is greater than negative 6, and 5x minus 2 is less than 6. I'll add the 2, so I get 5x is greater than negative 4. Divide by 5, and we get x is greater than negative 4 over 5. And when I do the same thing for the other one, add the 2 first, we get 5x is less than 8. We divide by 5, and we get x is less than 8 over 5. Notice this one's pointing left, this one's pointing right, so they're actually facing each other. It's going to be from negative 4 over 5 to 8 over 5. Now for number 9, before I can even separate these into a positive and a negative answer, I'm going to go ahead and add the 3 in order to get this to be the absolute value to be by itself. Then I'm going to go ahead and divide by 4, and we get absolute value of x plus 2 is less than 4. Now I can go ahead and separate it into a positive and a negative answer. So it's going to be x plus 2 is greater than negative 4, and x plus 2 is less than 4. I'm going to go ahead and subtract the 2 to get x is greater than negative 6. Subtract the 2 to get x is less than 2. Again, then pointing towards each other, so it's an AND. So it's going to be from negative 6 to 2 in parentheses. Now I'm going to do the same thing for 10. Start by subtracting the 8. So I get the negative absolute value of 2x minus 1 is greater than negative 2. I will divide by that negative 1, so that's going to give me the absolute value of 2x minus 1 is less than or equal to 2. Now I can go ahead and separate this into a positive and a negative. Now keep in mind, when I divided by this negative 1, this sign flipped, so it became less than. So the same rules of solving an equation, inequality, still apply. So we're going to get 2x minus 1 is greater than or equal to negative 2. And 2x minus 1 is less than or equal to 2. I'm going to go ahead and add the 1. So we're going to get 2x is greater than or equal to negative 1. I divide it by 2, and I get x is greater than or equal to negative a half. Then I go ahead and add the 1. So I get 2x is less than or equal to 3. X is less than or equal to 3 over 2. So they're looking at each other. So they're going to be from negative a half to 3 over 2, both of them in brackets. So I'm going to subtract the 5. So we get 7, x plus 2 is greater than negative 1. I'll divide by 7, and I'm left with x plus 2 in absolute value is greater than 1 over 7. I don't know why I wrote negative 7. It's not a negative 7. Okay. So we get that the absolute value of x plus 2 is greater than negative 1 over 7. Again, we have a negative number right here. So this is not possible, so it's a no solution. So for this one, again, you're going to separate them into 4 actually, because you have one equation right here and another equation right here. So we have, I'm going to separate them. One is less than or equal to the absolute value of x, and we have the absolute value of x is less than or equal to 4. Now, we have to separate these into their positives and negatives. So I'm going to just go ahead and rewrite this as the absolute value of x is greater than or equal to 1. So I'm going to go ahead and write them just like we've been doing. X is less than or equal to negative 1. X is greater than or equal to 1. So these are pointing away from each other. And then this one I can separate again. X is greater than or equal to negative 4. And x is less than or equal to 4. These are pointing towards each other. So if I were to put this in a number line, so you guys have an idea. So we're going to have negative 4, negative 1, 1, and 4. We know that the negative 4s are pointing towards each other, right? We know that the negative ones are pointing away from each other. So our solutions are going to be where these sections overlap, which is actually right here in between the 1 and the 4 and the negative 1 and the negative 4. So your final answer would actually be from negative 4 to negative 1 bracket, union, bracket, 1 to 4. So if you need to, you can always graph them to solve it. If you're able to just see it, that's fine too. If you rearrange them in order, for example, I'm going to do it up here. Negative 4, we know it's pointing to the left. Then the next negative number is negative 1 is pointing, negative 4 is pointing to the right, negative 1 is pointing to the left. Then we have 1 is pointing to the right and 4 is pointing to the left. So you're able to see how they're also paired up into negative 4, negative 1, and 1, 4. As long as you put them from most negative to most positive, you guys should be fine. You can also always graph them like we just did. I'll graph them so you guys always have the option. I'll show you both ways. For 15, we have the exact same thing. So we have 0 is less than the absolute value of x minus 5. We have the absolute value of x minus 5 is less than or equal to a half. I personally like to rewrite it with the x on the left side of the equation, so I'm just rewriting the 0 is less than absolute value of x minus 5 into the absolute value of x minus 5 is greater than 0. So I can go ahead and do, well, x minus 5 is less than 0, and x minus 5 is greater than 0. Now remember, 0 doesn't have a positive or a negative value. So we're just gonna do it both ways, see what happens. We're gonna get x is less than 5 and x is greater than 5. Now, because x is neither positive or negative, I will just keep the one that is the exact same sign. So I'm just gonna ignore this one for now. If I need it, I'll go back to it for the time being. If it's 0, just keep the original. And then for the other one, I'm gonna go ahead and do, well, x minus 5 is greater than or equal to negative a half, and x minus 5 is less than or equal to a half. I'll go ahead and add 5 on both sides. So I'll get x is greater than 9/2. And when I add 5, I will get x is less than 11/2. You guys can write it in mixed numbers. You don't have to. It's really up to you. Now, if I were to graph this, 9/2, so I'm going to just do 4, 5, and 6. That's kind of where these lie. 9/2 is 4, I think it's 4.5, so I'm going to put it right here. And then 11/2, it should be 5.5 if my memory serves me well, so I'm going to put it here. So we have 3 points. We have a point right here, close circle, and then an open circle at 5. Now let's figure out how we're going to write this inequality. They're telling us that 5 can go either left or right. So 9 is going to the left, this one's going to the right. So we actually don't need the 5 except for the fact that it's not included. So you would write from 9/2 included to 5, parentheses, union 5, parentheses, to 11/2. If you guys wish to write it with mixed numbers, this will just be 4.5, and this would just be 5.5. So just keep that in mind. So for 14, we have the absolute value at the bottom of the fraction. Now, that's fine. All you have to do is multiply by it. So times the absolute value of 2x minus 3. You do that to both sides, so that's going to cancel the denominator. So you're left with 1 is less than or equal to 5. And then times the absolute value. I'm just going to go ahead and write the absolute value of 2x minus 3. But since we want the absolute value to be by itself, I'm going to actually just go ahead and divide by 5 on both sides. And I get 1/5 is less than or equal to the absolute value of 2x minus 3. I'll rewrite it with the x on the left side as I prefer. If you'd like to keep it on the right, that is fine too. I just personally prefer to write it on the left. Now, after I write it on the left, I can go ahead and start solving it with the negative and the positive 1/5. So it's going to be 2x minus 3 is less than or equal to negative 1/5. And we have 2x minus 3 is greater than or equal to positive 1/5. I'm going to go ahead and add the 3 on both sides. So that will become 15/5. So it's 2x is less than or equal to negative 14/5. Now I'm going to divide by 2, which is the same thing as saying multiplying by a half. So I'm going to get x is less than or equal to negative 7/5. Sorry, positive 7/5. That 15 made it positive. There we go. Positive 7/5. Now I add 3 again on both sides. This will become 15/5. So we get 2x is greater than or equal to 16/5. Again, I'll divide by 2 or just multiply by a half. Is the exact same thing. And we're left with 8/5. So we have this one pointing left, this one pointing right. So it's going to be from negative infinity to 7/5 with a bracket, union, bracket, 8/5 to infinity. If you wanted to graph it, you can just go ahead and do the number line and do 7/5, 8/5. We know this one's a closed circle and it's going to the right. This one's a closed circle and it's going to the left. If there's no questions, guys, you guys do have homework on web design. It's only 6 questions. It'll take you about 30 minutes. There's a few questions on equations. There's a few questions on inequalities. And there's only one that you have to graph. But I made sure, at least on my end, they look like whole numbers. So hopefully when you get your question, because I know they're different, you will also get whole numbers. But if not, that's it for today.